Hello, Algebra 2. I hope you guys are having a fantastic day. Today we're going to start Chapter 2, which is about, well, the whole chapter is about quadratics, which is the square function, parabolas, lots of different, these kinds of things. Okay, so parent function that we're focusing on in this chapter is the quadratic, which is the same thing as the square function, which is the same thing as a parabola. Okay, so typically, that's supposed to be a T, quadratic. Go ahead. Okay, so typically, if the max degree on x is a 2, right, if you have x squared and then a bunch of other stuff, and nothing higher than an x squared and nothing lower. I mean, you can have lower things, but like you have to have an x squared. Then you'll have a quadratic or square function. And so there are three different forms of the quadratic function. The first is standard form. Then you have factored form, and you also have vertex form. And we're going to talk more about each of those forms individually as we go throughout the chapter. But I'm going to just write them down so that you have them, you know that they're coming, and that's the plan. Alright, so these are the three different forms of the equation of a parabola. Standard form, so all the letters, the A, B, and C, M, and N, H, and K, those are all constants, okay? And we're going to talk about later when we get into those, we're going to talk about what they actually mean and what information they give you. But just for right now, those are typically just numbers, like y equals 3x squared plus 2x minus 4, in which case c would be a negative 4. But anyways, that's the deal. So let's start graphing some parabolas. Okay, what if we wanted to graph one of these? So first option, and always kind of like a fail-safe, because if the other things are confusing to you, you can always make a table, or if you have your calculator, make a graph using your calculator. But say, for example, you don't have a calculator, and we want to graph this function, f of x equals 2x squared plus x minus 3. Easy, not fast, but an easy way to do it is make a table. So what I typically like to do is I like to make my x column and then my f of x column. And every time I always include the function that I want to use. So I write the entire thing. And I know that sometimes you're going to want to skip steps and you're not going to want to put that on there, but I will guarantee you, well, okay, not guarantee, but I'd say like 90% sure you'll make a mistake if you don't do that. So show your steps, write down the entire function, you'll be good. So then you can start picking different values of x to plug in. Now, I would not pick values like 10, because then you'd have 10 squared, and that would be awful. So let's pick a couple of negatives, a couple positives, and see where that takes us. So I'm going to start at like -2 and go to +2. Alright, so if I pick -2, I need to find out what f of -2 is. So I will take my function, f of x, and I want to plug in -2. And so then I would plug in, I'd have 2 times -2 squared. Okay, don't forget your parentheses there, because otherwise it's going to look funky. Plus -2, and you'll make mistakes. Overuse parentheses. Okay, so then you've got 2 times -2 squared plus -2 minus 3. Okay, because you plugged in -2 for x. So -2 squared is +4, -2 times -2. So I've got 2 times 4 plus -2, which is the same thing as -2 minus 3. And then I continue to simplify. That equals 8 minus 5, right? 8 minus 2 minus 3. is minus 5, and that equals 3. So our first point is negative 2 comma 3. So then you can just plot that on your graph. Okay, so here's negative 2 and positive 3, 1, 2, 3. So that's my first point. Okay, next, pick another value of x, because that one dot doesn't really tell us much. We do know it's going to be a parabola, but it could be this parabola, or it could be that, not that parabola. It could be that parabola. It could be this parabola. You have no idea. So you need some more points, okay? So I pick another point, negative 1. I got to find out what y is. So I plug in negative 1 to the function, and then I have f of negative 1, and then simplify. All right, so if you plug negative 1 in to the function, then you get y equals negative 2. So then that's our new point, negative 1, negative 2. Okay, so then I have another point, 0, negative 3. I'm not going to keep going through all of these steps. If you're struggling with like making the table and finding the points, come to office hours, because it's the same process each time. So I'm not going to go through that every time. But so then you'll continue to get points. I'm going to finish the table and then make my parabola. So this would be a good time to pause and try it on your own. And there you have your parabola. Not too bad. It's a little time consuming, I will give you that. So it's not the ideal way to do it, but when in doubt, if you're ever worried about anything not working out right, the table always works nicely. Okay, so another way to do it, if it's in the right form, okay, what you see below is called vertex form. And so if it's in vertex form, the transformations are really easy to see. And so sometimes you don't need to make a table, because you can just like take the basic parent function, which is x squared, and then transform it. So I'm going to draw the original parent function, y equals x squared, on the graph in black, so that you can see what's happening as we work through the problems. If you feel confident about the transformations right now, pause it and check your answers. You don't have to listen to me explain every step. I would just make sure, and then if you get one wrong, go back and listen to it, okay? All right, so if we started out with y equals x squared, or f of x equals x squared, then looking at g of x, we have two transformations, right? We have this plus 2 on the inside, and then the negative outside the function. And so if you guys remember the transformation stuff, right, if I change the x squared to an x plus 2 squared, that's going to be horizontal, so it's opposite of what you think. So plus 2 means it's going left 2, and then that minus out front is a reflection over the x-axis. So once you know those things, then you can easily sketch a graph of the new function. All right, so that's what g of x looks like. Make sure you label it. So if you noticed down here, I labeled that function g of x, and I'm also color coding. You don't have to color code. I just find it's an easy way to like organize stuff, but you do need to label. If you don't label, I won't know which function you're talking about, and then I could think that you're doing the wrong thing. So make sure you label. All right, next function is h of x minus 4 squared plus 1. Again, it's in vertex form, super easy to see what the transformation was, because it has that x minus 4, that whole thing is squared. It's not just like x squared minus 4, right? It's the whole thing, x minus 4 squared. What that means is that there's, it's horizontal again, it's going right 4, and then that plus 1 on the outside, that means up 1. All right, so that the purple there is h of x. Also notice that I labeled it. Next one is I of x, okay? And that one has that negative 2 out front. The negative is again a reflection over the x-axis. And the 2 is a vertical stretch by 2. So it's going to go from here to like, right? You're like squishing it, like pulling it up, right? So if you're not sure what the values should be, pick a few points, like I said before. So like the point 0, 0, that's not going to change at all. But if x is 1, instead of it being the point 1, 1, it's going to be the point 1, negative 2. So you can use that information to kind of like formulate your graph. And the last example is this negative 2x squared. And the difference between C and D is that that negative 2 is part of the thing that's being squared, which means it is affecting the x, not the y, meaning it's horizontal, not vertical. So this negative inside the parentheses is going to be a horizontal reflection. So it was this, and now it's that. My arms don't go that way, but you get the idea, right? Like they just switch sides. And so it actually doesn't change anything. That reflection over the y-axis doesn't actually change anything. But then the 2 does. That's a horizontal compression by a half. So again, you could pick a few points, pick a few values of x, just so that you know what's happening, but it's going to look similar to I, except not reflected over the x-axis, just because, remember, a vertical stretch looks very similar to a horizontal compression, but it's not going to be the same. It's not, in this case, it's not the same, which I can show you tomorrow. If you're curious, let me know. I'll tell you. Something else that's nice to remember, if you know that it's a horizontal compression by a half, that means all of your x values were multiplied by a half. So your y value stays the same, but your x value does not. So like, for example, if we're going back to the original function, right, this 0.1, 1, that x value should be multiplied by a half. So it's actually a half 1, so it's right there. Same thing with the other side. The negative 1 is multiplied by half. You get negative a half, comma 1. It's another point. The point 2, comma 4 becomes 1, 4 because you're multiplying, again, the x by a half. So if you know that, then you can kind of eyeball where the function's going to go. And that's j of x. All right. Last but not least, we're going to talk a little bit about vertex form of a quadratic function. So I already gave you the basic function up at the top here. That's vertex form. But I'm going to tell you what the letters actually mean in this case. All right. A is any vertical stretch or compression. So if A is a half or 2, then you know that it was vertically compressed by half or stretched by 2. H and K make up your vertex, and the vertex is like the point at the top, or the point, if it's an upside down parabola, the point at the bottom, right? It's like the maximum point or the minimum point, depending on what your parabola looks like. And so H is going to be the x coordinate of the vertex, and K is the y coordinate of the vertex. Also not a coincidence that that's the minus H, right? That's your horizontal shift. And then K is your vertical shift. All right, so there's your important information there. Vertex, make sure you know that vocab word, because I'm going to use it a lot. And if it's in quadratic, if the quadratic is in vertex form, the vertex is really, really easy to find. So that's really nice. It's nice for graphing, especially. All right, so for the next 2 problems, go ahead and use that information to try A and B, and then I'm going to write out the solutions, explain a few things, and you're good to go. So for A, vertically stretched by 3, so there's a 3 outside, and then 3 units left means we have a plus 3 in here, right? And basically, because your original function is x minus h, that means that that's really x minus negative 3, and so h is negative 3. That's why, and that's related to the opposite on the inside and horizontal's opposite, all that fun stuff. So that's why that's a plus 3, and then the plus 1 because it went up 1. So then for B, your horizontal compression should go inside the parentheses. That's 3/2 x. Translated 2 units down is outside, and then the reflection over the x-axis is out here. Now, something to think about is, what if I pull out the negative? What's the transformation now?